Hi, everybody. Thank you for coming. Thank you for being here. I have 25 minutes to go over 25 years of research. So I may skip a few things, but feel free to find me later and we can talk about it. So, if we're waiting for technology to solve our security problems, then it could be that the great security solutions we're waiting for are already dead. And this is a problem we have. We have lots of new technology that we're using to foster old ideas about security. We think we can make it better. So let me put this in your heads. Right now, we are in the alchemy stage of security. We haven't gotten to chemistry or material science yet. Yeah? So we're still back in the alchemy stage, which is best practices. That means some of you are making bronze using iron and copper, but you don't know why it works at some altitudes but not others, in some environments and not others, and you're sharing this. That's best practices. And you're trying all of these things, and as long as you don't blow up, then we don't do that thing anymore, right? And this is where we are with security. Now imagine right now if electricians didn't have to know how electricity worked, yeah? And so this entire building, this entire infrastructure, would you feel safe if they didn't have to do any math? If they didn't have to know what are the limits of the things they're building? If they didn't have to define these things? No. What if the electrician said, well, we kind of did it this way in this house, and that didn't catch on fire. So let's just do it here on a bigger scale, and if it catches on fire, well, we just don't do that again. And yet we're building out our security from small to great scales with that same mentality. And this is something that we've been going after for 25 years, is trying to figure out what the hell is security? Where does it come from? How can we measure it? How can we go from alchemy to chemistry? How can we bring this to the future? And I'm telling you, it's not technology. We have really, really cool technology, and we use that technology to make our bronze spears better. We're not actually improving what we understand about the science. So I'm going to jump, because I don't have much time, I'm going to jump right into one of the things we found with technology, looking into quantum mechanics. What we find is that, this is something you all know, is that in matter, basically everything goes, second law of thermodynamics, everything goes towards higher entropy, higher latency. So disorder, error, introduction. So if I drop a glass on the floor, that glass will shatter. And for me to rebuild that glass takes a lot of work, a lot of energy to get that glass back to where it was. So the natural state of matter is to go towards higher entropy, higher latency, yeah? But what we do know now about quantum is that there's quantum wave information. And what happens here is that you have something like paper, you burn that paper, and you end up with ashes and gases, yeah? But the wave information on a quantum level remembers that it was still paper. And we can use that to recreate paper with a certain amount of work and energy. Can't do that today. But we know it can be done. We know the information is there, that it will remember that it was paper. So what does this mean? Well, this is interesting because it shows that security seems to follow a natural state of quantum information. So what happens is this information wave goes on. Entropy and latency go down or stay the same. Yeah? So basically what you have is this wave of information. Over time it self-corrects, and it looks for order. And they think this may even happen on a genetic scale with our own DNA. There's a lot of research, it's very new stuff, and of course you have a lot of people talking about, the sun revolves around the earth kind of stuff. You don't know. We're still at that place now, but we do have some facts about this. So we do know that in nature, the fabric of the universe, you have basically two things. You have matter and you have this information wave on a quantum level that is a matrix across everything, which lets you know that these things are in symmetry. And there's even talk about whether or not dark matter may actually be the weight of information within these waves. And of course, there's scientists who say it's ridiculous, and those who say it's brilliant. You don't know at this point, yeah? None of this has been proven, except for the fact that we do know it exists. That has been observed. And so what we know is that in the symmetry, one is disorder and chaos, and the other is order and correction, which shows you that security is part of the fabric of the universe. It's part of where we are. So this takes us to understanding that security, everything that we need to know about it, starts with entropy and latency. We are trying to correct entropy and latency in any kind of security that we're trying to do. Physical, wireless, network, all of that. And so what we see is that we can break down security into these two parts, entropy, latency, and in which case, please forgive names, we call controls, properties. Whenever you do something like this, trying to come up with the right words is really, really hard, so be forgiving. There's going to be mistakes made. And all of this stuff you see here is the result after 25 years to get here. So again, like I said, we skipped over a lot of stuff. But so basically what you see here is that we come down and we've got our controls and our properties. And there's an example here, you see that identification, and it has a specific terminology. Now this terminology doesn't just come out of my ass. This terminology comes from the fact that these have specific properties that we have learned over the years through observation and testing. And so we know that these have properties. Think about a periodic table. There's specific properties that line up, and you can guess what is going to be the next element. You can assume, you can pretty much predict. And that's what ends up happening, is that this stuff becomes predictive. And so we know that identification, labeling and categorizing characteristics from the target of the interaction and the act, and blah, 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 yes? But it's a very exact, quantifiable definition. Its property becomes about accuracy. All interactions are anticipated and conform to known processes. So this is something you can do. Property, this is a control. This is something you would put in place. It gets more complicated. So it turns out that security mirrors trust. How do we know that it mirrors trust? Well, security are things you can control. Trust is not something you can control. So I cannot control this guy here in society. I can't control him. Well, if I could, I'd put him in prison, right? That's the whole point of a prison. But if I didn't want to put him in prison, but I wanted to be able to trust him, but I didn't really, I would monitor, I would do things to be aware of certain properties that change or give me reason to think I can't trust him anymore. And this is so true today that if you work in an organization, you may not have the political clout, you may not have the social status, whatever it takes, that you say, hey, I can enforce these controls on this person or this group or this department, especially in these international conglomerates, you know? Like France has no say over what Spain does in the same corporation. And so, but yet you are responsible for those servers, and in which case you would then you would have to use something like trust controls. But trust controls don't exist. Nobody ever talks about it. Nobody's even defined it. And this is part of the problem. So if I ask any of you, what is the definition of a square? I'm sure most of you could come up with a pretty good definition because it's something quantifiable. It has 4 sides equal, right? And then if I ask you something about define the properties of an element on the periodic table. Pick any element, and you'd be able to tell me, because right there you have a number of protons. You have some characteristics that it has. It might be a metal, it might be malleable, it might not. Those all exist. But then if I ask you to define trust for me, tell me what trust is in a quantifiable way, or security, and you all know security. Give me a definition of security in a quantifiable way. And the thing is that before this research, we couldn't do it either, because we didn't know. But again, you can't move science into the science age from alchemy unless you can start quantifying things, unless you can start actually having limits and understanding if things are finite or infinite. In which case, so we know that security and trust are on the same plane. It's just that one, you can touch things, the other you can't. It's the simplest way I can say that. But trust, since everything comes from quantum wave, that means it also has to follow entropy and latency. It has to correct those, yeah? And in which case, we can look here and we say, all right, on that same plane that we were looking at with identification and from before, identification and accuracy, we have here exoanalysis and components. So, for example, if I can't do identification because I'm not allowed to put controls on you, I can do a trust control, exoanalysis, the continuous analysis of the target for new or changed characteristics. So I can just watch if something changes about you. I think that's like how every cheating spouse ever gets caught, right? And then from a trust property, now we started with this back in like 2006, so we're evolving with this a lot. But we look at this as a property of trust components, the number of characteristics that relate to a target and can influence the trust. So I'm not just trusting this guy here, I have to trust his wife, his church, his partner, his best friend, whoever can influence this guy. Whoever is going to, because I think I'm talking to him, but maybe he's going back and be like, hey, this guy wants this, or he wants to do this kind of business. What do you think? It's no longer between me and him. But I don't know his components. All right. So if we look at this in a structured yet adaptable approach for navigating complex and evolving situations, we have this. So in the end, we're looking at anti-latency, anti-entropy. Yeah? And so what we get here is we have trust properties, security properties, trust controls, security controls, right? And that's how they line up, because they mirror each other. This is how this sits, yeah? And if we look at this, all of this then comes down to 5, well, I don't know if we call it properties or what, I don't have a word for it. But we knew since early days on that there was environment, interactions, interventions, and inquest. And these were the 4 ways that you can analyze anything. You go watch House, Dr. House there or whatever, and every time they go to analyze a new disease or something, they use these 4 things. And we recently found that there's a 5th one too, characteristics. And so you can see we've got it defined. Visibility is what is identifiable. Induction is the environment. Interaction is mutual, reciprocal. But they all are definitions without doubts. We know exactly what they are. It's a very specific thing. And then we look at this and we say, okay, from these, we get these 5 properties, whatever, I don't have a word for it, yeah? And this is what we have to look at. These are the only 5 things that we have to look at for each and every one of those controls and properties. So they all fit together, yeah? If you sat down and you said you wanted to do anything, analysis, figuring out what assets to protect, whatever it is you want to figure out, you follow these 5 things, and you will cover all of it. As ridiculous as that might sound, that covers everything that you may have to think about. Yeah? So here, if we apply it to assets, we know that characteristics, okay, so the assets we have are identities, customers, distributors, products, vendors. Context, we got your environmental space health, comfort, safety, again, because even if you're talking cybersecurity, you don't want to have to hire or fire people, and have to deal with rehiring and all that. So this goes through. So you can apply these 5 also to assets or anything else, like I said. Gets even more complicated. So it turns out that there's no now. So most security is built on reaction today. And I can tell you that's where the burnout comes from. A lot of the problems with SOC operators you see with burnout on pen test teams, blue teams, there's a lot of burnout. It's because most of the stuff we focus on is React, yeah? And it turns out that there is no now. So React is just what's happening on the timeline between before and after. And we have to figure out when that now is and how will we react. And so we call them intent, react, and resolve. And in which case here, we can take this same 5, sorry it didn't match, try getting it on a slide, you know. But that's why I have the cool arrows, you can figure that out. So here, identification happens before the interaction. Authentication happens at the interaction, and non-repudiation happens after the interaction, but they're all the same thing. They all deal with characteristics. They're all the same. Now the crazy, there's a lot of crazy stuff that comes out of this, but it turns out that if you prepare, let's say, in intent, or you prepare in resolve, and you set yourself up to capture either non-repudiation or identification, you are most of the way to authentication. Everything that happens in the React column can be done before or after. There is no time. That's the weird thing about it, is that time travels both ways. So for example, you set up your system for great non-repudiation, and you're gonna know what happened, when it happened, what were the characteristics of the person on there. You have almost everything you need for authentication. And you can already start working on that. It's just a matter of saying whether or not they can do that. Now, authentication is just basically issuing a challenge to validate a characteristic. It's a login and password, for example. Could be anything, a certificate, whatever. But anyways, this is the weird thing. So everything that we know about operational controls and operational trust all comes down to these 3 time zones, so to speak. And I'm sure, I don't know, 10 years from now, I'm going to find out how stiff and how elementary this is actually, and maybe there's thousands. What do I know? This is all ongoing research. And the way I like to explain is that imagine you start with a puzzle, a 1,000-piece puzzle, where every puzzle piece looks identical and they're all blank. And only when you match up any of them, you get a little bit of a picture. Yeah? And so you're going through and you're matching up all of these puzzle pieces. And I mean, it could get worse. Maybe you don't know how many pieces there are altogether. So you keep putting them together until you get a picture. And once you get a picture, you'll get a little bit more. And this is where things take us. So from year 2000 to, 99 to 2010, we thought we did a lot, right? We were looking at this picture, but in the end, we were like looking at this. And we thought, oh, that's got to be a landscape, obviously. That's, like we had an idea, and we're like, this is great. But then at some point, we realized as you're putting them, as you get more picture, you have less puzzle pieces to try, and you start coming along, you get more and more, and it happens faster. And this is basically what happened, is that as we had more picture, and then at some point we realized that there's also a picture underneath. And if you look under a glass table, you would see another picture. So now I have 2 pictures to work with, and I can work much faster. And I start filling in the puzzle even faster. And then at some point, I realize it's also projecting a picture on the ceiling and on the floor. So now I have 4 pictures. And I have to figure out what to do with that. And so basically, this is how this research is coming along. We've done more in the last year, probably the last 6 months, than we had done in the other 24 years, Anyways, so this is what the big picture looks like when we actually map out all the trust and security properties, and the controls. And so you see here you have different times, so you have intent, react, resolve, and they're broken down. And I can actually tell you that when your security is too React heavy. I can tell you when it's too intent heavy, to resolve heavy. Actually, there's a lot of really interesting properties that come out of this. So, for example, if I take the intent properties, I can use these 5 to say without a shadow of a doubt in court if what you did was malicious or not, or accidental. I have it defined. Here, I can take the controls and I can actually build, if I take the intent controls, I can actually build out, predictive security that allows you to de-escalate a situation before it even happens. So this is where it gets weird. So we had this, and at some point, maybe a week ago, we knew that there might be a negative, but we didn't know what it was. We thought the opposite of security is attack. That's what we thought. But it turns out that when we flip around all the trust properties, we end up with privacy. So it turns out that the negative of trust turns out to be privacy. And we think that the negative of security is offense or attack, but we're not 100% sure. But if we look at this, we say, okay, a trust property says, here, components, number of characteristics. Privacy says, reducing the number of characteristics that I could know. So it turns out that privacy is the negative of trust, which means if I need to trust this guy here, the more privacy he gets, the less trust I can have in him because I know so little about him. Yeah? It becomes an offense, which means, and I'm going to throw this obligatory out there, zero trust has to be 100% privacy. You can't have other way. That's the only way it works. So basically, we need to move forward doing this kind of research. Now, there's all sorts of things we've been able to do. We can predict new technologies. We have built so many new security technologies with this. We've defined all sorts of new attacks, which I've been told not to talk about here, not that we give anybody ideas, that haven't been invented yet. There's a lot of stuff that goes behind all of this that we're just unlocking like crazy and getting better and better ideas. And this is all going to be in Osstmm 4. Obviously, we're going to water it down. But this is where the research is going. And we have an incredible amount of bizarre knowledge, just weirdness, that we're learning all the time about security and what it means to apply it in a practical way. So that means, for example, the latest one that we just talked about the last couple days is negative knowledge proofs. So since I know that there's perfect symmetry in nature for security and trust and privacy and attack, I can actually then say, I can measure one by how much of the other is missing. And I can actually prove things, which means I can also look at, if I wanted to attack a website, if I wanted to attack a compound, anything, I can look at what controls, what trusts are there. I can define exact types of attacks that would work. I can tell you exactly what phishing attack would work. It's precise at this point to an alarming degree of what we can know, both good and bad, about security. So, anyways, thanks everybody. Thanks, Pete.